Our learning topic for today is sets and the real number line. Our first definition is a set, which is a collection of items called elements. Braces, which are these curved brackets right here, are used to enclose the elements of a set, and elements are just the pieces that are in a set. If nothing is contained in a set, it is called an empty set, and we can indicate an empty set with these two symbols right here. Now, a real number is a definition that we're going to have to understand pretty deeply and often throughout this course. So a nice definition of a real number is any positive or negative number that has value and can be expressed on a number line. Real numbers contain natural, whole, rational, or irrational numbers, as well as integers, but not imaginary numbers, and we will be defining each of these types of numbers. Additional symbols that we're going to talk about today is the ... which means it goes on forever, this backslash, which reads as such that, and then this funny looking E, which means it's an element of. So if we have a number, we could say it's an element of the set, such as. And we'll talk about that more. So now we're going to look at subsets of the set of real numbers. Now remember, a real number is any number where I can understand its value and I could place it on a number line. So now we're going to define the different types or sets of numbers. So the first set is natural numbers, which is denoted by this double bar n, and it is the set. Notice I'm using braces for set notation, and it starts with 1, and then 2, and 3, 4, comma, ... because after a while it gets probably pretty repetitive. I know what's coming next. The pattern has been established. This is also often described as our counting numbers. So it's the numbers that we learn when we are young. So counting numbers. Whole numbers are all of our natural numbers, but also contain 0. So whole numbers is denoted by a W. So the set of whole numbers, it starts at 0, and then it's the same exact thing as natural numbers. Now whole numbers then leads into integers. And integers, which is a Z, are our whole numbers, but also the negative of our whole numbers, such as -2, -1. But then, as I said, it's all of our whole numbers, 0, 1, 2, etc. And then this leads into our rational numbers, and this is a bit more complex. So the definition for rational numbers in the set is denoted by a Q. I'm just going to bring this up a little bit. Is the set of P divided by Q such that P and Q are elements of the set of integers. There's that Z. But remember, we are not allowed to divide by 0. So Q cannot equal 0. Now, division indicates ratio. So rational numbers, ratio, is the ratio of integers. And some examples of ratios of integers could be a number such as 5/11, or -1/2, or 9/1, which would then just be 9, or 0.6 repeating, which means it is 0.6666. It goes on forever. Now, irrational numbers, I can't draw this arrow here because rational numbers and irrational numbers are almost like the reverse of each other. So irrational numbers are real numbers. They're still real. So they are real numbers that cannot be expressed as a ratio of integers. So I want you to be thinking about this as you're writing it down. They cannot be expressed as a ratio of integers. And the other thing that makes this different is their decimal expansion neither terminates, it doesn't stop, nor does it repeat. So it does not terminate or repeat. So an example of an irrational number, very famous, is pi, which is approximately 3.14159, and it goes on forever. It does not terminate, it does not repeat. Another example of an irrational number is the square root of 2. It's still a real number though, because I can understand its value. It is approximately 1.414. Now you have to be careful there. That looks like it's repeating, but if you were to put this into your calculator, and I encourage you to do so, you're going to see that the next number, it's not a 1, it's different. It does not repeat. It is irrational. And the last set of numbers that we're going to talk about, notice I have this line here. I'm separating this. These are not real numbers. These are imaginary numbers. And these are numbers that I don't understand their value. An imaginary number cannot be placed on a number line. So numbers that are not real, do not have a real value, and an example of an imaginary number is the square root of -1. And if you were to put that in your calculator, and I encourage you to do that, you will get an error message in your calculator. Try that out. You're going to get either an error message or something else that's going to say that this is not real. So now you are going to have a question, and the question that you're going to answer in the video is identify the elements of the set B that is equal to, and we have 1, 2, 3, 4, 5, 6 elements here, and I want you to tell me which of these elements belong to the set Z.